Visualization Speaker Series event. I think we can clap for that. I'm very excited about it. I have a couple super quick announcements. First, this is sort of the boring stuff, but it's really important. I want to thank the Dean's Office of the College of Arts and Sciences. They're the ones who funded this event and helped us coordinate a million little things just to get this happening. So if you are enjoying the food and wine and whatnot, you can thank them for that. And especially Chris Brooks, who's here somewhere, who's here in the back. Thank you, Chris, for your support and helping us get this started. The idea of this speaker series is this is just our first one. We did sort of a test run last year, but our hope is USF semester is almost over, but we're hoping that next in the fall semester and future semesters we'll continue to bring back really excellent speakers like you're about to see tonight. So thanks Chris for that, and also thanks to Lisa Watson who helped coordinate a ton of stuff. She's not here tonight, but we'll keep her in mind. Sophie Engel and Alark Joshi, my colleagues over here in computer science. Woo! Some of you are required to be here tonight because you're in Sophie's data visualization class. Everybody else, thank you for coming. Also, I want to thank our student volunteers who helped out checking people in. Mindy, Broderick, and Kayla. Thank you very much. And that's our last little thank you. I'm very excited. We have Reza Ali here tonight to talk. I'm not even going to introduce him because you sort of know that his work is amazing. That's why you're here. So welcome, Reza.
Cool. Thank you, Scott. All right. So I'm going to do something a little experimental today. This talk is going to be a lot about designing visualizations and interfaces with code, and these are just some of the key things that I sort of extracted off the meetup description, which is all true. But first, so I'm going to be showing some work that might be a little bit intense, and it's probably going to have some strobing images. So if you're if you're sensitive to that, just look away when there's like crazy stuff going on. My name is Reza. You can find me on Twitter @Reza Ali, and if you want to tweet at me during the talk and ask me a question, you're welcome to. I'll have my phone right here for questions later. So this is going to be experimental. We can take the red pill, or we can take the blue pill. But I didn't prepare anything normal, so we're going to take the red pill. And so just diving right in, the whole structure of this talk is an application. It's pseudo-generative. It's kind of like a slideshow meets a monster. So what I'm going to be just doing is like flipping through these things, and then we'll see some work, and we'll talk about some concepts, and I'll drop little nuggets of hopefully knowledge or maybe just weird things. And hopefully you can learn something from it. So I'm really excited to start. And so I'll give you a little bit of background about me. I'm just a researcher, artist, maker. That's what I do every day. I'm a full-time artist at the moment. And I was a researcher for a big sort of like phone company before, and I used to make stuff in LA for, in visual effects. So these are the things that I'm really interested in, and I will be talking about them today. I hope that some of you guys are interested in these topics as well, because I think they're kind of future. This little bar right over here represents the timeline of the presentation. So when it gets red and really small, you'll know that the presentation is going to end, and then when it gets to 0, the app will just shut off. So, so it gives me a good way of just like pacing myself. So when I got asked to talk here, I thought about like, what is it that I do and what can I share with you guys that is meaningful? And I think it comes down to not looking at visualization or data visualization in terms of like a class that you're taking or a field, but I think if you treat life as like Legos and like pieces of like areas of interest as Legos. So I love Legos. I used to make tons of stuff with them when I was younger. They're really like modular and you can reconfigure them. There's like an infinite number of possibilities. So that's kind of cool because basically it's only limited by your imagination. And today in our world, like I think the world that I live in, I'm constantly creating new worlds for people to experience, whether that's a website or an application or an installation. So it's really about like playing and escaping out of our reality and going into another reality. So keep that in mind, like all this Lego talk stuff while I'm like showing you stuff, because in the end of the day, we're all just gonna be playing with Legos, and that's like the most enjoyable thing you can do. So this is the talk. This is one slide that just randomly shuffles through these images. So it's really going to be about designing generative visualizations, interfaces, code, and the process that I have when making this stuff. So the first thing I'm going to show you is just some sketches that I made for a show called Modulations, which was held at Karma, which is at Stanford. And the show was all about bringing like abstract electronic artists together with sort of abstract visualists and seeing what they can make. So the first thing I'm going to show you is this thing called Morpher. And to give you a little bit of background of what Morpher is, it's an audio reactive mashup of two generative systems visualized in real time. If that makes no sense, don't worry about it. I'll explain it in a little bit, but let's just play with it so you get an idea of what I do and what I make, and I'll talk about more about it in a second. it's morphing shapes, and there's two systems working and sort of playing with each other. So that was one sketch, and it was composed of a system from two systems, and these systems are just models of how things are going to move and interact with geometry or space or data. You can model many, many systems and match them up to create, a really complex sketch, or you can just model something really, really simple and have one system playing its part. The next one I'm going to show is called milk and coffee. You know that when you take milk and you mix it in iced coffee, and it does this beautiful pattern, and it just goes through and it comes back, and it's just like a visual orgasm. So I'm obsessed, clearly, and I want to show you what I've done to make milk and coffee. So this is like instant gratification. So there's points. They're connected with springs, and they're basically tracing out the audio waveform. And there's a fluid field in the background, and what's going on is as these points move, they're changing the velocity vectors in the cells in the fluid field and increasing the density. It's basically like having a fire hose just putting in milk into the coffee. I think it's kind of neat because, for example, with this system, right now it's just blown up, and when you create these systems, there's a certain level of control you have over these systems. Like, for example, if I make the milk sort of decay and go to zero, like just someone's extracting out this fluid. It kind of works better with how much sound is going in. So I want to show you a couple presets that I made. So this one is a bit more, the line is a little bit more sort of elastic. This one's really simple. This one's just visualizing the waveform, but given some damping. And whoa is just like, all right, these points, if I tell them not to go to sort of like mimic the audio waveform, they'll just spread out in space. It's really interesting because this whole system is dynamic, as in like you change one parameter and it will do something completely different. So, for example, if I turn down the spring constant, if I tell the rest distances to go back to what they were, and tell this guy to go home, you start to see what's going down. And now you can kind of see, all right, that's what I was doing before. And then you can tell it, hey, just keep doing what you're doing. Sorry, that's not, anyway. So I treat these as like little Legos, like I could explain to you fluid dynamics, but that's not going to be a task I can do right now in a couple minutes. And I can explain to you dynamical systems and control systems, but that's also really complex as well. So these, basically, once you start learning these things and building little systems on top of them, you can compile like all these things and make complexity. So let's go back. Let's get recentered for a second. All right, that was milk and coffee. There's another one called formalized. This system is very kind of basic, in my opinion. There's a differential equation that defines a chaotic attractor. And a chaotic attractor is just something that defines velocity vectors in space. which will tell particles how to move. And if that sounds like craziness, it is crazy. So we're just going to look at it really quick. This one's kind of erratic. I really haven't figured out how to control it, but so when something is generative, you're basically modeling a system where you have some sense of control over what the algorithm is going to do, but there's a lot of parameters in the system that can make it do all types of crazy things. So when I'm designing sort of these visualizations, what I'm doing is trying to understand what these systems are going to do, but also manipulate them in a way that they're going to do kind of what I want them to do, and also sort of like let them play out as well. So you can see what's going on in the data. The data is actually going through. These are the parameters of the differential equation that control sort of like how these points are affected in space. And you can see right now, if I hook this up to piece of audio, basically having the audio affect these parameters, they're going to go sort of vary over time, and that's going to affect the visualization. And you can kind of see that happening. Okay, so that was that. There's one more called Plexus. Plexus is there's like an effect called Plexus Effect in After Effects. Basically, what the Plexus Effect is you have particles in space, and the closer, like let's say two particles are in the same sort of region, there's going to be a line drawn between these two particles. Let's say there's a bunch of particles in space. It might be a couple triangles drawn, or triangles and lines. So you can start to make really interesting sort of like complex images with the Plexus Effect. It's really like popular in visual effects in Hollywood and all this stuff. It's like basically it's a sign of complexity in relationships between things. So what I want to show you guys is like this thing called Plexus and my take on it. How did you get these particles to behave in that way. So in my work, it's really about control. Like I'm sort of type A, so that reflects in my work. That's why there's a million sliders everywhere and whatnot. So I basically want to like break it down so it's like kind of simple. If you have a particle in space, it was born somewhere, and you can tell it to go back to where it was born. So that's just called a homing effect. So it just goes to any other point in space, right? So there's, if you look at the system, over here there's a sort of slider called homing power. You turn that off, and they're just going to float out into space. They're just like drifting out. That's great. If you want that effect. I kind of like them to be a bit more sort of anchored. But there's also other effects you can have. Like, for example, if you have, let's say you just have a sphere in space. Like, for example, like we're going to turn this on. Here's a sphere in space. So these particles are now attracted to the sphere, which is kind of cool. Another thing is, turn the audio. Cool. So another thing is they're on the sphere surface, but they're kind of not evenly distributed. So what you could do is just turn on this electromagnetic repulsion, which will basically just distribute them over the sphere evenly. And that's kind of cool. And then there's another slider called electric distance. Basically, that's going to control how far that threshold is for finding a neighbor around and connecting them, or drawing a line between them. So if we turn off this debug, you can kind of see there's a lot of lines being drawn out. My computer does not like that, but we're going to do that anyway. So that's kind of cool. And then complexity is basically built upon like small things or small little algorithms working together. So let's say we have another sphere in space, so we just activate this guy, and now we have something that looks like totally like far out. Like here's a ring of particles, and that's just basically because two spheres are acting on. And let's see, let's just change the camera perspective. So it's kind of cool. And then if you turn the power of one sphere sort of down, you'll see that it will be attracted to the other sphere and match that power. And it's also being visualized in the interface. You can see like as the power goes down, this thing fades out. So this is sort of my way of learning as well as visualizing actually what's going on. Kind of powerful for when you're dealing with these kind of systems where you don't know how they're going to react to what you're doing. So that's another system. Then there's this thing called distort. Basically, you can put anywhere in space, just put an attractor that will basically suck in all these points like a black hole. So and these behaviors are infinite. You can think of many behaviors to give these particles, and you can just build them out of math and physics and just add them to this particle system. That's one way of building sort of complexity, just keep adding these little small building blocks. Cool. All right. So I guess I want to stop showing work for a second and maybe talk about like the audio aspect. When you look at audio, typically see, let's say, so you can see what's going on over here is like there's a waveform, this is the spectrum, this is the average volume over time, and this is the simple beat detector that just triggers on beats. That's one like key aspect of the work. Talked about generative systems. So I was actually at Wikipedia generative systems, and it gave me a long definition followed by this line, basically. Express more complex relationships between observed and target variables. And I could probably think of like, what was that about? And the best way I can explain them is if you look at plants and how they grow, it's really simple. It's actually really complicated, but you can kind of think of a tree that grows and then it branches off and then that branches off. So there's some sort of algorithm there. Or if you look at birds and how they're flocking, you can see that like there are a couple rules that they obey to sort of have that pattern, or ants marching. If you also look at chemical reactions, you can see that there are certain rule sets in place for how two chemicals will mix together, make new chemicals, or just sort of fizzle out. So what I think it is a system based off a simple set of rules and/or interactions in which the outcome is unpredictable, yet precisely calculated. Hope that's a little better. These systems can be modeled via algorithms and simulated. So I'm really interested in the modeling and simulation. And that has sort of led a lot of my research. Inside of the computer, you're basically manipulating data with these generative systems, whether it's a particle's position, or its color, its relationship to the particles around it. Data is essentially nature. There's a great website called Data is Nature by Paul Prudence. You should check it out. It's everywhere, it's everything, and it is so hot right now. It's like very, very kind of crazy, especially in Silicon Valley, and here data is like very valuable. So we have to learn how to control data and how to like sculpt data into something that we can actually use, because there's so much data, like insane amounts. So because the data hasn't become self-aware yet, hasn't started mining itself, we have to give it some love. So one way is to visualize that data, which clearly you guys, hopefully some of you guys are doing, which is great. So this is like a really simple visualization. So the microphone volume over time, the X and Y, like mouse positions over time. So this is one way of visualizing that data. But I always ask myself, what does this mean? Or do we learn anything? Can we even use this? Like this pretty graph, that's great, but what is it going to do for me? So data analysis is the next step. So one of the most important parts is not only to look at your data and make it like look pretty, but then analyze the data and figure out what are the patterns and trends. So for example, what I'm doing here is just plotting the kicks and hats and snares over time of me talking. Of course, it's not accurate, but we can sort of look at this guy, put on some music, and see what happens. There's this slider out called threshold, so that allows me to like control like how sensitive this speech detector is, which then renders better visuals. So that's the way I've been sort of learning from data, and this is sort of infinite. Like you can apply this sort of like analysis to like various types of data. I just decided to do it to music because it's what I'm really passionate about. And what's another interesting aspect of this is sort of average volume over time. We can sort of do something. Let's see. Okay, so we can do something. We just control this slider. This is going to really affect sort of the visual outcome. So you can see that I'm talking here. So manipulating data and analyzing data is very important for actually getting the result that you want. So you should just be fearless and just go at it. And, okay, so one other aspect of my work is real time. My process is all about real time. So real time interaction, real time visualization, real time feedback. I wish I could code in real time, but I don't think I can work that fast. So real time is significant and important because you get that immediate feedback. You're essentially playing a video game with whatever you're doing, and it helps you understand the system in a way that it's almost a new way of learning and understanding. Real-time interaction can allow you to do things that sort of the static, sort of looking at a graph will not allow you to do. Like when I change the sliders on one of my visualizations, I can see the effect of what's going down in real time, and I understand the system and I've learned something about it. So I would highly encourage you guys to play with processing or open frameworks or Cinder or some sort of framework that allows you to create real-time graphics and do some visualization there and see what you can learn there versus sort of working in, versus like static, sort of like SVG or sort of graphics that aren't sort of performant. So, like I said, kind of type A, and the interfaces are everything in my work. So, the more params you have, the more possibilities, but the more UI controls you have, the more complexity. So how do you manage all this complexity? Sometimes the complexity isn't a bad thing. I think when I work, there's a process where when I first create the system, I expose all the variables possible. There's tons of sliders, tons of buttons. And over time, as I've learned what they do and how they manipulate systems, I sort of take them away because I know the right values for them. I can figure them out, and they sort of help me with understand what's actually going on. The interface for me is beyond just manipulation. It's also about learning. So this is a piece called Cyclo, and I was really interested in waveforms. Waveforms are really interesting because let's say. Okay. So, what are we looking at? Okay. So, cool. We all know, you should know, that what a sine wave looks like, right? The left channel is visualizing a sine wave. And we all know what a cosine wave looks like. A cosine wave is just offset of sine wave by 90 degrees. Right now, these are both in phase. So this plot is basically plotting this sine curve. This is also plotting a sine curve. And this is the sort of end result. It's a 2D plot of the x and y values taken from the right and left buffer. If we were to, for example, change the right phase to be out of phase, you see, okay, we've made a circle here out of 2 buffers of data. It's kind of interesting to me. I think, in a way, the interface allows you to learn these sort of relationships in a way that when you got taught math class in high school or middle school, you just saw this and learned what phases meant. I think that'd be a way more intuitive way to learn. And then if you learn about, okay, well, you can also speed up, sort of have this waveform traveling, right? You can see, okay, see the circles doing some pretty interesting things. And if you say, okay, well, instead of a circle, I want a triangle wave, what does that do? So, this is my way of learning. I just visualize things and I look at them and I try to understand what's going on. And the interface is my way of sort of doing everything. So this is one interface. You can also do things on the web. You can do things with paper, but they're not as fast and fun because you can't sort of script them and make little algorithms to sort of show you. Anyway, I'm gonna play with this a little bit more and just show you some sort of cool relationships you can form. I was really inspired by this duo called Alvinoto. They have some really great work and visualizations of waveforms in general. So I can't take credit for this amazing sort of like discovery. They're the ones who originally sort of found this and shared this with the world. And, so this is interesting. Like this pattern is fascinating to me visually, and it's just a triangle wave and a sawtooth wave. You know, that's fascinating. Cool. So let's go back, and so really quick, just want to break down. So like my process, higher level view is just a combination of researching, designing, making, and then reflecting what I'm doing. I think realistically I spend about 30% of the time coding and 70% of the time just like, you know, tweaking sliders. Not kidding. Because coding is actually pretty easy once you get sort of like proficient at it. It's kind of like just chopping wood, you know, just get good at it and you're like, all right, that was great. But designing is a whole other thing. Like coding is like, you have a math problem and you have to write an answer, right? But designing is kind of like, you're gonna write an essay and you can use the infinite amount of words that are there for your disposal. So the design really takes more time than the code. So just remember that when you have your projects or homework assignments or future things, because the design process does take a long time. One interesting thing is when I am working, I think there's an interesting concept of like compile times. So when I work in C++, things have to compile. And the interesting thing about that is like as the compile times get higher and higher, the number of iterations that I perform, like, you know, sketch iterations or design iterations go down, but the amount I reflect on the work goes up. So a lot of the work that I've done in sort of like a compiled language is way more, like, it has way more like thought. It's been way more thought out. I think it's deeper and it's reached a new level of sort of like of being versus when I work in JavaScript, the compile times are like 0 because you get that instant satisfaction, which is great for doing multiple iterations. But sometimes you don't get that reflection time. So just be aware that when you're working in different sort of programming languages and environments that will also affect how you actually, or like what you actually make. So one last thing is I want to just talk about interface insights. So we talked about like how interfaces can expose things and help you understand things. This is just a noise function, a two-dimensional noise function. And what's going down is like these noise functions, typically you have one input and the next input that gives you this sort of input over time. What you could do is just sort of learn how this noise function works by just saying, okay, well, if we take the first input and slow down, you know, because that's basically a timer is going off and we're just scaling how fast it's going, right? So I think I have like insights like this where I'm making something and I plot it and I look at it and I'm like, oh, okay, that's the actual signal. Like, that's what's going down and being fed into my system, and that helps inform me on like how I'm going to use that signal or how I'm going to sculpt that signal to affect systems. This is kind of important when it comes down to motion and just understanding the data. So, new media, this is sort of this general field that I work in. And I think the reason why it's so interesting is because it is the modern day Legos. Things like processing, open frameworks, Cinder, Arduino, 3D printing, like open source, smart materials manufacturing, tech shop, the internet, JavaScript, and like, you know, servers and stuff, the cloud. Sort of, they're so accessible at this point where you can go deploy your app on Heroku.com in you know, an hour and have the whole world interact with your things. And that's really powerful from a builder's perspective because now these Legos aren't just things you're playing with on the floor, but things you can actually share with other people out in the world. So these new media Legos are like really cool. They're so hot right now, but you actually need the glue to put these Legos together because they no longer fit in nice little like Lego pieces. So I sort of broke down what's sort of necessary to like kind of to put these pieces together, and it's just a combination of like some math, algebra, like y equals mx plus b. It's like a equation of a line, right? And geometry, like basically how those lines are related to each other at angles and vertices. Calculus, like basically what does d over dx mean, right? It's basically change of position over time, which is velocity. Things like that. Differential equations basically is super important. It's basically when you have systems that are changing over time that are based off parameters of the system. So like, one really basic differential equation is like a damper, right? The damping in a system is based off the velocity. So the damping force, which is the force is equal to F equals ma, which is equal to some constant b times v, right? So that's the differential equation right there. You have to simulate that to see the effects of that differential equation, and that constant b affects how the system behaves, whether it's underdamped or overdamped or sort of like properly damped. I think underdamped systems are great because, well, I can get into that anyway. Physics, music, signals and systems, art, just having an open mind and thinking about ideas, not so much as in like we're gonna do some arts and crafts, but art as in like asking questions and making things that evoke emotion. Design and design thinking, I think these two things are kind of interesting because they're almost polar opposites. I made a lot of art, designed a lot of things, and I think every time I designed something, it was so the problem would go away. And every time I made a piece of art, it was so I could like make people stop and look at the problem. So, just remember that architecture, abstractions are really great. I kind of like play with logic and coding, and of course fearlessness, right? This is something that is really important. I think in my work, I don't stop till I get to where I need to be. And when you are coding something, or what was really interesting is like I think fearlessness is like super important, and it's super apparent now. And you can get feedback like almost instantly, like when your app is not working. But if you're fearful and you're like, oh, I can't do it, then you're obviously not going to get anywhere. So just keep trying. That's one thing that I would like to tell you guys. Anyway, so I'm sort of done with the talking part. I make more than I talk, so thank you for listening to me ramble for like the last, I guess, it looks like it was 45 minutes-ish. So now I'd like to basically show you some more work and just take questions. So the next work I'm going to show is fluidscapes, and that's more explorations of fluid dynamics and fluid fields and how they affect topology and meshes. So as I'm showing the work, I'm going to be just playing with it. I'd love for questions about anything and everything. I know that sometimes I probably just like went way too far in one direction. So, question.
Can you talk a little bit about the tool set you're using to build these visualizations? Did you custom code it? Is it based on an existing framework, etc.?
So the tool set that I use right now is basically C++ and Open Frameworks. Open Frameworks is it's basically a collection of a bunch of libraries written in C and C++, mashed together, and their API is basically really nice because it's similar to processing's API, but you have like a couple advantages. So my stuff is built in Open Frameworks. It's using OpenGL. It's using GLSL, which is basically little programs that run on your GPU. The tool set includes everything from Maya to Photoshop to Sublime text to pen and paper. But the main environment for producing work is this thing called the resonator. And the cool thing about the resonator is this is just a framework that I've put together that is a collection of all my sketches, so at any point I can just show you guys anything and everything. So here they are. So like if you wanted to see something I did a while ago using bullet physics, these are just small experiments, so I don't show these as actual works, but they're just like little explorations. Or if you want to see a clock made from like cellular automata, there's another one. So the environment is just something that I've built myself for myself as a way, it's like a software studio. I would highly encourage everyone to get familiar and comfortable with at least one sort of working environment, whether it be, 3JS or D3 or possibly frameworks or considered, so they basically feel comfortable implementing whatever algorithm you sort of find that's interesting. Cool. Did that answer your question?
Yeah, it makes sense. If I understand it, you built a bunch of sliders yourself on top of all these big frameworks.
Right.
You sort of use this IDE to bring it all together.
That's right. So I totally skipped that part. So yeah. So this whole thing is a small framework. Oh, I guess it's kind of big now, but it's a thing called OFX UI. It's an add-on for open frameworks that basically gives you a lot of things like sliders and buttons and text areas and waveform graphs and tons of stuff. Like there's more stuff. It's been like 3 years in the making, and I've ate my own dog food many, many times. And that's why today I was just like, what am I going to do my presentation in? And I just decided to code it. Oh, yesterday. I didn't do it all today. Crazy. I could show. I can show another thing. It's called Cosmic. This is an interesting piece because it deals with n-body sort of per particle interaction, and I guess the cool thing about this one is that all of it is done on the GPU, so it's all GPU based, which is kind of neat if you're into GPU based programming. So it starts off with nothing. That's disturbing. Let's see. This one is broken. Sorry, guys. But it looks really cool. It looks like this. Maybe after the talk, if you're really interested in that, I can show you. Let's talk about Voronoi diagrams and puzzles. So one of the projects that I've been sort of working on recently is getting back into the physical. So we have a lot of these visualizations and awesome things on the internet and on our sort of computers, but there's nothing more satisfying than 3D printing something and holding it in your hands. I think it goes back to like making things with your hands. There's some sort of satisfaction you get from actually, doing work that's not just computer-based. So I'm just going to show you how this is. This is like an insight of my process of like how I go about designing these things, right? So it starts off really, really simple. It starts off with an empty sketch, and then what happens is like typically I'll study the concept. The concept is a Voronoi diagram. What is a Voronoi diagram, right? It is basically a diagram that subdivides space, and the space is subdivided based off of points put in a space, right? So let me just go ahead and turn up the point size. Still too small. Okay. Well, let's go to the next one. So these points, if they move around in the cell, you can kind of see, oh, this is kind of interesting. They're sort of the diagrams update in real time, and you can see how the points move and how they affect the cells. Some faces, some cells go from 5 edges to 3 edges. Not so much in this one because they're all just sort of moving a little slowly. It's interesting if you have sort of the same concept of like having a sphere in the center, and if you have the points attracted to the sphere, you get this kind of sort of tessellation pattern. But if you apply that concept of like electromagnetic sort of repulsion, they'll sort of spread themselves out evenly. So, and if you visualize their sort of like history over time, you get this sort of like organic kind of diagram of like movement. And then if you were to take that movement and say, okay, we want to see that in 3 dimensions, what does that look like? You get something like this, which is kind of neat, because you're visualizing, basically this is a 4-dimensional visualization. It's like you have X, Y, and time is represented as well. Well, this is 3 dimensions then. Anyway, so my process is basically like I study research and I make, and then I'll reflect on it, and then I'll go ahead and just do another run. So the whole point of this one was to generate 3D puzzles that you can 3D print and play and make. So the tool was instrumental in being able to understand the algorithm, to implement the system, to visualize it, and to capture the 3D data and export it out to Maya. So the software is more than just like a web app. It is everything. It is the way I learn. It is the way I express myself. It's how I make my presentations. It is really central to how I work and operate. So it's a little disturbing because sometimes you code too much and you become a little like a bit weird. That's normal. Anyway, so that's how I make puzzles. I did this thing and I visualized Gray Scott's reaction diffusion, and that's a differential equation that defines how 2 chemicals mix. There's a question?
Yeah, so what are the costs of sliding sliders is really a hell of a lot. Forget where you are, forget where the interesting stuff is. Can you speak through how you manage that?
The complexity and the interesting?
Yeah, I mean, what do you do in order to, the sliders are all there.
Yeah.
Like you have a bunch of avenues you can explore.
Yeah.
What do you do with that?
Well, I save them out. So what that means is like there was a presets tab on everything, and what the presets tab does, it allows me to, actually this is a great question for this one. This one's not working. Let me just do something real quick. So that was a great question. Let me show you how that works. So typically, cool. So whenever I find a preset that's really sweet and that I really like, what I'll do is I'll save that, and that's just a matter of pressing this button right over here in the top left, and I'll save and load. So that's also built into the studio, where I like save these things to a file. So that way, if I wanted to, for example, pull back a blobby setting, and once I click these presets, they'll update every slider button here, and you'll get sort of call that setting back. Also, the software studio contains everything that I have to like, let's say I want to create a large print that's the size of a wall. There's a tile saver. Basically what that does is just, it tiles the window and saves out every image, so you can make a really, really high resolution render. There's also a GIF renderer, so if you wanted to like export a GIF out of a beautiful moment that you found, that's really easy. So I've sort of been working at this for a while and sort of discovered like if I could just stay in one sort of area, one zone, that's really going to help me sort of focus and just get whatever I'm doing done. So I'm just going to go through some GIFs. So these are GIFs just basically taken straight out of the program and compressed a little bit in Photoshop to get on the internet. So I like to find these beautiful little moments of emotion. Sometimes it's really just hypnotic. But what's really interesting is like there comes a point where the complexity is you build so much complexity when you look at something you have no idea how it's made, and I think that's magical. And that's something that I couldn't do by myself. I had to use a computer, I had to use technology to be able to create it. I think we're in the sort of like day where technology is all around us and it's not going to go away. So we really have to learn to like embrace it and learn like what is, how are we going to work with it as a sort of like as a tool, but also just an entity in itself because we're so engulfed in it. So a lot of these pieces are just, some of them are glitches actually. Because sometimes a preset is not good enough. You need an image, or you need a GIF, or you need something to share with the world. Because you can't just share XML files. That's not fun. This was actually, these images are from Cosmic. Actually, oh, sweet, that's awesome. So this is Cosmic right here. It's a really fun part of the system. Let me show you what it can do. So you can randomize it, just give these guys a little bit of velocity. You can also change, how big the sort of circles are. There's one sphere right now that they're being attracted to. We turn on another one. And you can kind of see what that does. If we're not sure where these spheres are, we can just turn on the debug. Radius. Okay, cool. You can see what happens when we increase the repulsion of each particle. So I think in a lot of ways, I've just been trying to understand a lot of these systems so I can just use them as design tools. Like, for example, in Photoshop, when you have filters, they're just there to help you accomplish your design. I'm sort of interested in understanding these systems and having these little systems where I can just sort of pull them out and say, okay, we're going to borrow pieces of this system, we're going to mash it up with this system, and we're going to create the next generation of coolness. So a lot of the client projects that I do are basically extensions out of just doing system research by myself. So a lot of my own personal work fuels a lot of like things that make it out to the world that are new and novel. I think it's really important to do that research so you can make these things.
So I noticed like a lot of your work starts out using black and white or grayscale, or starts out with talking about like and some work stays black and white.
Right.
But when you transition to color, and you do how do you work with color in a generative way, that's always a challenge.
Right, that's a good question. I used to work with color a lot, And then when I realized I didn't know what I was doing with color, I stopped working with color. And that's when my work went exclusively black and white. But there are still some things that have color. And the way that I work with color is, what I do is I just have a folder full of color palettes. And they're basically just like a 5 pixel by 1 pixel image that has a different color in each pixel. And all my sketches are made in such a way that those color palettes are just taken in and you can apply them to the system. Because you might have 100 particles, you might want every particle to be that same one color, or you might want, actually let me show you this one sketch and I can show you what color does. So this is one way that I've worked with color before, where, for example, if I'm saying nothing, let me show this to you. Okay, so the way this is working with color is that there might have been a color palette that was given to me by a client per se, let's say. And what I'll do is I'll look at that palette and I'll extract out the key colors in that palette and see how to apply that to a system. So right now, if we look at this, there's a huge panel that just goes beyond. The color is being, like I can choose a palette that will basically just put a color on, and I can change that palette with a slider. So you can kind of see it's going down. Or you can work in white or black. Or you could have reactive color basically based off the height of the system. So as they extrude upwards in the Z, they'll change into this more, basically go through the color hue circle. Let's see, another way of working with color is just dynamic. So there might be a color palette that sort of slowly changes over time, but that's also a function of the extruding height. So typically what I do with color is like, I'll have palettes that are like pre-selected that I like, and then what I'll do is I'll think about displacement or force or velocity or acceleration and sort of figure out how to properly map that color palette to that system. So for example, another interesting use of color would be these fluidscapes that the color palette is there, right? And what's going down is there, as these things extrude upwards, the color palette changes from that. I'll typically have a slider that controls that very carefully. So like color intervals, that slider itself. So now the color palette is like not so good, it's a little different. And then I'll just sort of look at it, eyeball it till it looks interesting, just sort of right. A lot of this piece is an art piece, so I want it to evoke as much emotion as possible. I want people to feel something from the fluid dynamics. So that's why the color is very strong. A lot of my other works, they're just sort of design exercises. So, for example, oh, that's the presentation. Okay. Okay, let's check out this. This is sort of an interesting system that, so let me just frame this. So a company who does a lot of audio processing wanted to see their logo, or their new logo, in motion, reacting to audio. So there was an agency that approached me and said, okay, we know you do a lot of this kind of stuff, so what would you do visualize this sort of like interaction with their logo. So the process here was about, you know, taking, like, sort of approaching it from a conceptual point of view and saying, okay, well, what actually happens when you're speaking? You're creating sound waves. And these sound waves are affecting the air around us, and that air is going to, you know, it's going to affect our eardrums, and that's essentially going to like have us be able to perceive sound. So essentially, did the same thing here, where what's going down is there is a fluid field. Just turn off a couple things. So this is a ring, and that ring is being modulated by the audio waveform. Just very simply. There is there's a fluid field in the back that's just reacting to that. So the rings are pushing out, they're gonna push out. And then these points, they're basically took the SVG of their logo and then just created this path, particles and springs around. And then I said, okay, well, points are going to just react to the fluid field, and that was it. And it just looked right. And the color palettes were, you know, there's only 4 for a reason. There were even, you know, they selected a couple of color palettes. And then all these sliders just affect the aesthetics. But I think what's really interesting is the stuff that the client will never see, which is stuff like this, where it's like, all right, well, just turn off spring constants and the targeting of the phone. What happens then? This thing just flies around. So, you know, I like this stuff. This is great. There's a question.
Yeah, so as somebody whose life and work revolves around like building these 3-dimensional models like from nothing,
Yeah.
do you ever feel claustrophobic in like by virtue of the fact that like programming is kind of constrained right now to 2 dimensions, and like how like do you have like can you talk more about how you explore like real 3-dimensional space if you ever do?
3D printing. So that's a good question because I've been writing software, I guess, or I've been writing code for the last 5 years, and there came a point this year where I just had enough of it and decided to sort of get out of the 2-dimensional space and work in 3D now in the real world. So the real, not virtual space. I think there are certain things, certain technologies that are helping us sort of come from the virtual and go back into the real. I think a device like Motion is really pushing forward sensing in terms of 3-dimensional sensing. There's no 3-dimensional operating system or the Matrix or anything yet, but when there is, that'd be great. 3D printing is really great because a lot of the things that I make, I'd really love to see them manifest themselves in the real world somehow. And when that happens, things get real, and you feel things that you didn't feel before when they were just on your screen. It's really hard to throw away a 3D print, but it's really easy to put your project in the trash and have it be gone for the rest of time. It's really easy to have a 3D print last for 100 years, for many years, versus having a piece of software that constantly needs to be updated over and over and over. So I think the times are evolving and changing, but a lot of the tools to get back into the world are just being made right now. Sure.
What is your creating dynamic artifacts and things like that?
I think I'm all for them. I think that my thoughts on it are that naturally that's going to happen. That's why it was sort of listed Arduino and all these things are building blocks, right? We're building towards that. We're building towards trend architecture, reactive architecture, and products that aren't static but reactive. Just like the UIs we're building in virtual space, I think the internet is like one of the most cutting edge places in terms of UI, sort of like interaction design, right? Because everybody's on it. I think that the real world is trailing behind with these open source and like kind of community based projects like Arduino and open frameworks and processing. And the type of people behind them are the ones that are going to make the future and drive like innovation forward, because they're the ones who aren't limited by like, well, there's a patent on that, so we're not going to do that. You know, I'm all for what you just said actually: reactive architecture, trans architecture, spaces that sense us and sort of react to us are the future. We're not there yet. Well, we're getting there. Cool. Thank you guys.